I can see him. I think he's there.
Okay, so shall we start?
Yes, please go ahead.
Okay, good. So anyway, good afternoon and welcome to, good afternoon from England, and good day to everybody, regardless of where you are. And welcome to this event, which has been organized by the UK chapter of UAA in association with active alumni members who are living in UK as well as in the European Union region. My name is Niranjan, and I'm a professor of food bioprocessing at the University of Reading. But I'm a UDCTN, and I trained as a chemical engineer, did my BChem Eng, MChem Eng, and PhD Tech in UDCT several decades ago. So I would like to believe that I'm a thoroughbred UDCTN. Yes, the UK chapter of UAA was formed, I think, about just over 30 years ago, when we had a critical mass of active alumni living here. But then with other preoccupations and aging, the UK chapter became moribund for quite some time. With our last event, I think probably was organized in 2014 in Reading. More recently, Dr. Ram Sabnis, who is a member of the Board of Governors of UAA, contacted me and offered to help revive our activities, because we now seem to have more than a critical mass of members living in UK and EU regions combined. I was then introduced to Siddhant Prabhu, Bhargav Patel, and Abha Valavalkar. And when we all met, we felt that we could try and revive some activities, perhaps by organizing an event like this. At the same time, I also learned of the increasing number of UAA members living in the Republic of Ireland. And this gave me the idea to hold an event around Professor Vivek Ranade's experience as an academic entrepreneur. This is how we sort of got to this event. But before I proceed to introduce Professor Ranade, I would like to extend a very warm welcome to all those UAA members living in UK and EU, and encourage them to join us in forming a fairly buoyant group in Europe. Now, how we all come together formally remains to be seen. We could either form a regional chapter, or we could form several national chapters. So there are various options, but let this formality not come in the way of organizing events. If you have a good idea, please feel free to get in touch with one of us. I think Abha has offered to put our email addresses in the chat box. So if it is not already there, it will soon appear. So please feel free to contact us if you have a good idea and you want to organize some events in this part of the world. At the same time, I also understand that there are quite a few students from ICT who have actually joined this meeting. I certainly welcome them. And if there are students who wish to pursue further education or further studies in UK or EU, you please feel free to contact us, and we'll be happy to signpost you if we can. Right, now coming to this afternoon's event. Professor Vivek Ranade is the Bernal Chair, Professor of Process Engineering at the University of Limerick in Ireland. Vivek's biography is already in the flyer, which I hope you all have seen, and I have no desire to repeat it. But I would like to point out that I have known Vivek for several decades, embarrassingly long time. He is extremely bright and a highly accomplished chemical engineer. He possesses all the qualities that I have always aspired to, but have fallen woefully short because of my own shortcomings and innate inadequacies. I have therefore held in Vivek in extremely high esteem and looked upon him with sincere admiration. Vivek is an active academic, but he has also co-founded 2 startup companies. He is therefore extremely well placed to talk on academic entrepreneurship, which is his journey from the laboratory to the marketplace. But just before I hand over the floor to Vivek, may I just request all of you to mute your microphones. If you want to switch off your camera, that's also fine. But if you have any questions or comments, etc., please type it in the chat box, and we will take all questions together after Vivek has completed his presentation. The presentation, as I understand, is not too long, so there will be enough time, more than enough time, for interactions. So over to you, Vivek.
Great. Thank you. Thank you so much, Niranjan, or Professor Niranjan, I should say. Right. Great. Thank you. And I think you have raised the expectations quite a lot. I mean, first of all, you insisted on me on the catchy title, and with this introduction, I think my first job is to manage the expectations of the audience. But anyway, it's a UAA, so I feel at home to give this talk. And like, as I mentioned, Niranjan was insisting on a catchy title. Otherwise, normally I would not have dared to use journey or something like that in my title. When I was preparing and thinking about these slides, I realized that, well, I might be forgiven to use that journey because it's almost really 4 decades. Like, I was introduced to chemical engineering research in summer of 1983. So it's almost 4 decades now. So please forgive me for using this title like a journey of an academic entrepreneur. I'm a simple chemical engineering researcher. And what I want to do today is basically just share some of my experiences on my attempts of translating our research from lab to market, not just for licensing, but particularly by founding or co-founding startup companies. And I'm glad Professor Pandit is here. Vikas Kakade is also here. He has also contributed to one of the companies which I had co-founded. So I'm really glad to be here. And let me start my presentation. I don't want to. I'm sorry, I can't. Okay. Right. So as Niranjan mentioned, I'm a Bernal Chair of Process Engineering at University of Limerick, and we primarily use experiments and computational models so that we generate new insights, innovations, and intensification strategies, so that we can realize scalable and sustainable solutions. So that's what we do at my research group, which is called as Multi-Phase Reactors and Intensification Group. But the whole journey started at UDCT. I spent 8 years, like Niranjan. I did my graduation as well as PhD from UDCT. And it all started there. And in fact, if you look at the logo of my group here, Multi-Phase Reactors and Intensification Group, that has been inspired from King's Circle, right? And I don't need to emphasize the importance of King's Circle to UA folks, right? What I'm going to do today is, though this is a journey from 1980s to 2023, I'm primarily going to focus on 2 aspects of this journey. Tri-Diagonal Solutions, which was the first company I co-founded, and the second one, which is I'm still a director of, is Vivera Process Technology. That is what I'm going to focus on. But let me start on the rationale behind this genesis of these companies, and I need to go back to my NCL days there. So after my PhD from UDCT, I went to ETH Zurich. Spending a couple of years there, I went back to NCL in 1990. And that's where I started working on. I established a group called IFMG, Industrial Flow Modeling Group. And that eventually led to co-founding a company called Tri-Diagonal Solutions. And that's what I'm going to speak about today. And then, of course, I went back to NCL after leading Tridiagonal for some time and developed the project called IndusMagic, which eventually led to the second startup company, Vivira. And then I moved to Ireland in 2016, and I'm still figuring out what is going to come out of that Irish experience, which is still ongoing. And that's the content, that's the agenda for my talk today. I'll try to keep that brief so that we get adequate time for interaction. But if someone has some questions, feel free to interrupt. Just raise your hands there in a chat or give me a signal, and I will be happy to take it up. Okay. But let me go back to my NCL days. Like when I went back to NCL in 1990s, so many stalwarts were working in chemical engineering at NCL. Dr. Mashelkar had just become the director. He became director in 1989. Professor Doraiswamy was there. Dr. R.V. Chowdhury, Dr. P.A. Ramchandran, who wrote Trickle Bed Reactors book, and many others. Dr. B.D. Kulkarni. So many people were there who were working on reaction engineering, catalysis, kinetics, and so on. Process engineering was really a strong point of NCL at that point of time, and even today, but particularly at that point of time. And for a newcomer like me, when I was there after 2 years of postdoc experience, I was really trying to figure it out where I can work, what should be my focus in those days. Right. I would like to now, when I'm looking back, I could relate that experience to this figure, which is like a famous figure from one of the Levenspiel's book. After reaching NCL and started thinking about establishing my group, I realized that most of the work and most of the people working at NCL at that time, all those experts, were primarily using conventional methods. And there were not as much presence of computational fluid dynamics related work. And being my PhD in computational fluid dynamics work with Professor J.B. Joshi at UDCT, I then decided to focus on transport processes where we can use computational models as well as experiments. And that was the origin of my group, Industrial Flow Modeling Group at NCL. I realized that with all this catalysis and other background and expertise available at NCL, if I have to create my own space and my own research group, it is important for me to identify specific impact, specific research area which will have significant impact on chemical engineering research field applications, as well as it will be complementary to NCL. And then I figured out that maybe computational fluid dynamics will allow us to ensure that delivery of materials and delivery of energy at right time and at right place. So that was the focus in those days. And I started my group in Industrial Flow Modeling Group. If many of you may not be around at that time, but many of you also remember that in 1991, there was a financial crisis in India. So in fact, government funding essentially dried up. So when we were at NCL, the classical or a conventional avenues of raising research funding was to write projects to Department of Science and Technology and so on to get money. But in 1991, financial crisis, all those funds were really, really tiny. And Dr. Mashelkar coaxed us to really go out and rather than only applying to government research fundings, go out and start applying to industries, start approaching industries and raise research funding from industries. And I then quickly realized that there are 2-3 things which are essential if we really want to raise funding from industry. First of all, you need to have an identity of a group. So I very soon after joining NCL, in first couple of years, I self-declared my research group, IFMG. So I was the only member at that point of time, but it was important to create that identity of a group. And I created that identity of Industrial Flow Modeling Group. Why I am emphasizing this point is particularly when you want to raise funding from industry is looking for kind of a continuity, and industry generally would not like to just allocate or give projects which are really person dependent. That is because their conventional de-risking strategy. So it was important to establish that group's identity. Another point was I had written my code during my PhD time, and I had in fact expanded that code in my postdoc time. And I was in fact continuously working on that computational code at NCL. But I quickly realized as soon as I started talking to industries that industries won't really rely on a code which is written by a person called Vivek Ranade sitting in a tiny corner at NCL, right? So industry needs a platform which is more generally available. It is supported and it is sustainable. So I then fortunately got in touch with first of all Professor Spalding at Imperial College, and we signed an agreement with their code, Phoenix code, and then few years later we in fact signed an academic agreement with Fluent, which is now acquired by ANSYS. So currently Fluent belongs to ANSYS. So with those agreements, we were able to get commercial computational fluid dynamics code. And of course, because of the NCL's reputation, we had an access to large companies like DuPont, Invista, General Electric, and so on. So these three were really important factors which really shaped my thought processes at that point of time, and figuring out how computational fluid dynamics and computation models in general can really be used for making an impact on industrial processes. So identity of group, partnerships with commercial CFD codes, and access to these large companies by leveraging the reputation of NCL. Those three were in fact deciding factors. And that helped us to really generate significant amount of funding, which also helped us to build our experimental facilities, and more importantly, generated significant contacts in industries. And all that research work was primarily focused on developing new computational models, but mainly on multi-phase reactors and multi-phase processes. And those were also translated into books. So I wrote my first book in 2002, and I'm continuing that. So in 2022 also, I was able to write a book recently on flow modeling. So that was the background, and those formative years we developed our approach on using computations for innovations and implementing those innovations by further developing it so that they are suitable for implementation. And that background at NCL was really the genesis of the first startup company, Tridiagonal Solution. At NCL, we had an opportunity to work with wide variety of industries, but one of the issues in working with NCL is primarily the bandwidth. Right? So how do we, the number of projects which I was able to deliver from sitting at NCL was limited by size of my team. So that was one of the limitation, and also the inability to walk the last mile. Like for example, though we used to develop good computational models, we had no skills which will allow us to really make those models easy to use. So there was we didn't have ability to create kind of easy to use user interfaces which will wrap our computational models and make it more ready to use, more amenable to use, right? And that was the driving force for thinking about the startup company. Fortunately, Dr. Mashelkar by that time had become Director General of CSIR, and he had allowed CSIR scientists to start companies. NCL had also started a venture center, first of its kind for CSIR in March 2006. And all of these factors actually came together, and I then started seriously thinking about developing, co-founding a company called Tridiagonal. But of course, it took a long time and required a lot of convincing at NCL and within CSIR. So we really identified, I gave several presentations internally to discuss what NCL will do, what Tridiagonal Solutions, if we start a company outside, how that company and NCL will not compete with each other, but it will really complement each other. I required a lot of convincing to do. In fact, I need to identify specific benefits. I'm not going into details of all of these 2 slides. Just want to give you a message here that particularly an academician who wants to co-found, wants to start a company or spin out a company, it is important to ensure that the parent organization feels safe and feels not competing with the company, the company which is going to be spin out or started, right? So that was really important. It took some time because that was the first company from NCL. And I'm quite glad that after I did start this company in 2006, now there are more than 10 companies from NCL. Many of them are quite successful. So that was the genesis of my first startup company. It primarily started with the lack of bandwidth, but also on the productization. So that's what we essentially tried to do. So NCL focus was more on fundamental research, developing new computational models. In startup company, the focus was essentially productizing those models, writing easy to use user interfaces, and create more and more bandwidth. So that was the essential genesis, and resulted in, with my one PhD students and 2 associates from Fluent India, we started this Tridiagonal Solutions in 2006. So I was leading this Tridiagonal Solutions as a CEO for 2 years, 2008 to 2010. And I was still chairman of the board till 2014. Essentially, we significantly increased the bandwidth, first of all. Whatever I was able to do for 10 years at NCL, we started doing it in 1 year. So the kind of size of projects which I had handled in almost 10 years or 14 years, 1990 to 2006, all those 15, 16 years kind of impact, we started realizing in 1 year with enlarged team at Tridiagonal. Okay. There were, of course, different issues. I mean, managing the research group in an academic institute like NCL is quite different than managing a team of professionals at a startup company or a private company like Tridiagonal Solution. And I must acknowledge all the help I received from my PhD students. In those days, many of my PhD students have preferred to join this Tridiagonal Solutions company, and they have helped it grow. I mean, I must acknowledge their contributions there. Very soon, by 2009, 2010, we had grown up to 30 people. At 2010, we also raised and sought external investment. We got the external investor, which helped us to further expand the company. And I started realizing that I personally, maybe I'm preferring research kind of life rather than a CEO or CXO life of a private company. So I started thinking of going back to NCL in 2009, late 2009, and eventually decided to return to NCL. So in 2010, I went back to the lab, and that's where that was a second step. I must highlight here that the kind of impact which we could realize with Tridiagonal was otherwise would not have been possible if I had stayed just at NCL. So Tridiagonal really helped multiplied kind of impact which we could realize by those models which we were developing at that point of time. Tridiagonal is doing well today. It's more than 100 plus technical staff, and whatever products we had started developing, those have now really grown. And one of our product of stirred tank reactors, it is called as Mixit. It is now more than 80 licenses. More than 80 companies have licensed that product, including the big pharma. So this Irish, now I'm in Ireland, and many of these Irish pharma companies have a product which we had developed, at least initiated development at Tridiagonal Solution. So that was quite good. There were some challenges. Of course, I'm not going to talk about those right now. If there are questions on those challenges, I will be happy to take it up at the end. But let me go ahead with the story and tell you more about the second startup. So as I said, in 2010, I went back to NCL. because I had started a company on computational fluid dynamics and computational models in general, I decided that it is not a good idea to continue my research on flow modeling to avoid any sorts of conflict of interest. And you remember that this was the first company coming out of CSIR. So I wanted to make sure that no one points a finger at me of taking an undue advantage of NCL for the benefit of a private company. So I decided to completely change my research focus. So when I went back to 2010, went back to NCL in 2010, I started looking at what new areas I can work on. I realized that till that time, till first 2 decades of my research career, I was primarily focusing on large industries, starting from DuPont, like large multinationals, to Indian large companies like Reliance Industries and many others. After going back to NCL in 2010, I started looking at smaller companies, fine and specialty companies, where most of the processes were batch. Well, not as batch as this caricature of Octave Levensfield's book, the Omni book, which is shown here, like an alchemist doing something. But literally, topologically, reactors used in those fine and specialty chemicals were still quite same. It was like an agitated tanks. Agitator may be a little fancier than this bamboo stick, but it was kind of technology was of similar nature. And then it helped, that catalyzed the development of our large project, which I used to call at Indus Magic. So innovate, develop, and upscale MAGIC processes. MAGIC stands for modular, agile, intensified, and continuous. So that was rather new area for me. And I formulated this large project, which involved 5 CSR labs. Because of my age, I had become head of chemical engineering division by that time. And by the virtue of that position, head of chemical engineering division at NCL, I had now wider reach at CSR laboratories, and I could really brought in large number of scientists there, primarily chemists and chemical engineers together. So we started looking at many batch processes which were being practiced in Indian fine and specialty chemical industries, and we were then able to convert them into these MAGIC processes, into continuous processes. So we work not just on processes. Of course, there was a large group of chemists and catalytic chemists along with chemical engineers who looked at these batch processes and helped them convert to continuous processes. But we also started looking at devices in that Indus Magic project. So we used some of our computational fluid dynamics expertise, not for improving existing process equipment, but developing new types of process equipment. And then in that project, as a part of that project, we developed fluidic devices. So many processes we have transferred from batch to continuous. This is just one example, a pendimethyline, which was then licensed to industry, where we could replace 10 kiloliter batch reactor by 16 liter tubular continuous reactor. So that was just an example. We transferred several such processes, but those were via licensing route. What I want to talk to you about is the second startup company, Vivera, that is based on hardware. So apart from the processes, we also developed fluidic devices like hardware products. Some of these hardware products were licensed for manufacturing, like the metallic pinch tube reactor were licensed to Amar Equipment, glass line reactor were licensed to GMM Fowler. But we had some cavitation devices developed and patented under Indus Magic. And with my experience of tridiagonal solution, where we were essentially doing the consulting and software products based on computational models, when I was trying to sell those software products and consulting, I felt that if I had something tangible to sell, like a hardware device, it is much easier to sell. So that in fact prompted me to create this second startup company, Vivera, by licensing, by taking our patented cavitation device, right? My impression at that point was it is easier to sell hardware, some tangible fluidic device. It might be easier to sell rather than selling the software or the consulting. I mean, that's what I said here. Grass is always greener on the other side. When I was selling software or selling consulting, I always thought that selling hardware might be easier. I started second company and realized that that may not be so. But it did well initially. So we started this Vivera process technologies by for commercializing some of the fluidic devices. We won big grant of BIRAC. We were also won Innovator of the Year award. We scaled those devices up. We commercialized them. We implemented them in distilleries and effluent treatment and so on. Despite the good technology, we were into waste treatment or waste, essentially effluent treatment. And in India, at least at that point of time, I have heard that situation has changed significantly now. But the industries were not willing to pay money for effluent treatment, at least at that point of time, as much. Everyone used to talk about clean water and sustainability, but it is not a profit center. It is still an expenses. So we had tough time in selling our devices, particularly in waste treatment. So we are now currently, Vivera is still surviving. It's still a small company, but now rather than focusing on and using our devices for effluent treatment, we have started looking at value addition and transforming effluent treatment to effluent valorization or a waste valorization aspect. And I hope that some of these avenues will help us grow. Now, just to continue this story, I moved to 2016. So I formed this company co-founded with one of my PhD students in 2015. We have a team there now in India. But in 2016, I moved to Ireland. One of the reasons was essentially that rather than focusing just on effluent treatment, we can use some of these devices for other high value products. So after moving to Ireland, I essentially started looking at these new avenues, exploring new avenues so that I can still continue to work with Vivera and help it grow. So after moving to Ireland, essentially rather than focusing on treatment, I started focusing on waste valorization, and we did large project on grass or whatever waste biomass to biomethane. And we also have a large Indo-UK project, which we just recently concluded. We hope that Government of India has now this Satat scheme, which is encouraging this waste biomass to biogas or biomethane. And we hope that some of our recent research work can be leveraged by Vivera and can hopefully convert some of this waste into wealth. Besides this waste valorization at Ireland, I'm also initiating next step to Magic. So Magic, we essentially converted batch processes to continuous processes. Now we are working on development of factory in a box platforms. So essentially going a step further and create a modular and really decentralized ways of manufacturing high value products like say for drug substances or excipients or personal care emulsions and body lotions, food and nutrition and so on. So I'm not going into details of the ongoing research. Just two examples I'm citing here. One is on excipient. It can be slow release or fast release excipient, or we are looking at food and personal care emulsions depending on the requirements. We can tailor those emulsions in a truly tabletop factory in a box platforms. And we are using some of our fluidic devices in these platforms. So the goal essentially is to leverage our patented devices, further develop them, create a body of patents. We are also using these devices for intensifying reactions as well as downstream processes for high value products like pharmaceuticals. We are working closely with some of the large pharma companies, and we hope that these devices eventually, and the Vivera's experience of manufacturing these devices, scaling up these devices, will eventually help us to create a company, hopefully in Europe, which we can then leverage these devices and really expand application horizons of these fluidic devices. So as an academician, essentially the goal is to see the practical usage of your research. And all my career, right from NCL, it was primarily motivated by my NCL experience. Of course, UDCT has a rich tradition of translational research. And with that, I'm really proud to say that I've been constantly looking at applications of our laboratory research to practice. And these two experience of these two startup companies, Tridiagonal Solutions, which were primarily on computational models and software products, and Vivera Process Technologies, which is primarily on hardware and fluidic devices. We are now thinking that it might be useful to, in fact, combine these together. So it might be probably a best way forward is to combine consulting, software products and services bundled together with a tangible hardware product. And I still marked here a question mark. I'm still toying with variety of different ideas, but I hope that the current work and my past experience will allow me to expand either Vivira or create another company. That's what we are toying on. So that is where I would like to stop. And in fact, I will be happy to take questions. I know that this is rather brief and kind of a quick, but my idea was rather than sharing nitty-gritties with you, we can keep it open, keep some time for those discussions. And if someone is interested, we can discuss some of the nitty-gritties of startup or spin-out companies. But I just wanted to give you a flavor of why academic researcher would like to start companies and what kind of impact that can realize. So I'll stop here and take your questions. Thank you.
Thank you very much, Vivek. That was fascinating. I mean, you have sort of exposed us to dimensions that many academics won't even see. So I think that's from that point of view, you have done remarkably well. And I think there was a lot of information which is very densely packed here. I'm sure this is probably you could write a book on this, not just to give a talk. But anyway, the talk is open for discussion, and if there is anyone who would like to start, I can't see anything written on the chat box at the moment. But if there are questions and anyone wants to ask questions, please fire away. Can't be stunned, is it? There were 30 people there. I think how many are there now? 50. My goodness, that's a good number, I would say. We had more than 100 registrations.
Yeah, just a quick
go on, Vikas.
to Vivek.
Yes, Vikas.
Hey, Vivek, thank you very much for your ventures and giving us the good insight of how they have grown. And, thank you for mentioning my name also. While conceiving Tri-Diagonal, I was briefly associated with you on the business side.
Right.
But good to see that it has grown to 100 plus staffs that you mentioned. And I'm sure it would go to various places as well going forward. Just wanted to get a flavor of business volume in terms of, let's say, turnover or whatever of Tri-Diagonal specifically. For example, the last year, let's say year is ending. I hope it is March end only. So 2022, 23.
Right. No, so as I said, I have exited from Tri-Diagonal. I also exited as a chairman of the board in 2014, right? So I don't want to probably talk about those numbers right now. I think the Ashish, my other co-founders, which are there, those are there. What I would say that is like before I quit in 2010, for example, we had a revenue of 2 million at that point of time.
Oh, great.
Yeah.
Mm-hmm.
Yeah.
Thank you.
And I was leading and I left Tri-Diagonal, that was the number.
Yeah, because it was mainly on the services side, isn't it? So with 2 million, it's a great volume that time. Sure. Yeah, thank you.
There are questions from Sid. Sid, would you like to ask your question?
Yeah, happy to. Yeah. So, obviously kind of working through your academic commitments and teaching as well as, research commitments for students and then also commercial commitments to your organization. Can you speak a little bit about sort of some of the challenges with that and sort of how you overcame some of that?
If I can just add here, Vivek, it's how to balance is one thing, but very often there are conflicting loyalties as well. I think that is also, if you can combine the two, that will be great.
Right. I think the conflict was or is rather most critical, I would say. And like, as I said, when I went back to NCL, that was the reason why I had to I voluntarily changed my research area, right? Because that is in fact rightly so. not just in India. I think I've noticed it even in Ireland, like everywhere, that is the primary concern. And how do we resolve conflict of interest? I think best thing to do there is actually clear that at upfront. I mean, now when I went back to NCL, in fact, I created all those forms for conflict of interest, which are now quite common here in Ireland. For example, I've seen most of these universities have the standard process for dealing with conflict of interest. NCL also has that. Now, we had initiated that right from my time. So conflict of interest is, I think, the primarily thing, and that is best thing to do. That is declare them and then create that and address them right at the beginning rather than later. Because later can create a lot of complications. The balancing the commitments, of course, once you're having the PhD students and the outside commitments, obviously your work hours may go up. That's one of the disadvantages of doing too many things probably. And so work hours will certainly go up. But I don't really say that is anything special for a startup company. Many academicians anyway spend a lot of time beyond the stipulated times anyway for their research. So increasing work hours is not I would say a big issue. But I think managing conflict of interest is certainly is. And as I said, at NCL, I had to do really almost 2 years of convince. So I founded company in 2006 and took charge as CEO after 2 years later. And it took me some time to really do all that convincing. So
Great. There's a question from Hemant, and it says, please summarize 3 key do's and 3 key don'ts for the benefit of future academic entrepreneurs. Hemant, would you, can you, I mean, it's best if you can talk.
That's a tough question. Right. But I think, so do's, I would say that is probably common. I think, first of all, you should have a good creative idea of what you really want to do. That's, I think, a basis for that. Second thing is, like many times in academicians, we have certain notions about how applicable our work is, right? And particularly at NCL, we had quite a bit of surprises there when we say that we have developed a process in the lab. When you go to a industry and start talking to them about we have developed a process, their definitions of developed process and academicians' definition of developed process are quite different. So there is a gap between what we say, right? I mean, the meaning of same words is quite different for industry and for academic circles. So another important aspect, another important do's is to really be acquainted of these definitions of industry people. So you should have a good creative idea what you want to sell. You want to make sure that you talk the same language of your industry people. And third important thing, particularly for creating a company, licensing, these 2 are important. If you want to start a company, the executive team for the company is very, very crucial. Right. And I quickly realized that, like as I said, we started with 2-3 of my associates and we quickly grew to 30 people. And then I started realizing that, okay, this is not the job which I would like to do. So I was a CEO at that point of time. And it is much better that if you, even if the idea is yours and basic concept is yours, if you are not the right man to lead that, it is a good idea to hand it over to someone else who will do it better job, right? So that is what I would say, third thing, that do's. Well, don'ts, I think list can be several, but I'll probably need to think a little more if I want to prioritize 3.
Great. There is a question from Milind Chittale. Would you like to go and ask, Milind, or do you want me to read the question? Okay, I'll read the question.
Okay.
It says, we would like to know when you were able to convert batch reactors to continuous reactors. How was your success? And that is also a prospective work which could have given a lot of success. I don't know
Yeah,
what the
so-
last part means, but yeah.
Correct. No, so definitely. So we have in fact successfully converted many batch processes to continuous processes. The key point there was like there was no incentive for many plants to replace their existing batch plant to continuous plant, because that batch plants are old and depreciated. It is just giving them money. So there was no incentive to scrap that batch plant. But fortunately, like in 2010, our companies were growing. So they were typical Indian chemical industry at that time. Will, if you want to increase the capacity, just reproduce the same batch plant again at some other location.
Linear scale up.
Right. So fortunately, we were able to convince those plant owners that rather than repeating the same batch, why not try our continuous process? And we were really successful with that. And it has picked up. So in fact, in Indian chemical, now there are many other companies, startup companies who are actually doing this batch to continuous transformations in India.
Yeah. Vivek, I've got a very interesting question from an undergraduate student, and I think you should answer this. I won't let you off without answering this question because it's from an undergraduate. Okay,
Right.
It is Prashasti. Prashasti, would you like to ask your question?
Sure, so I'll do that.
Go on, go for it.
Yeah, thank you so much for an amazing talk, first of all. And my question is like from an undergraduate student point of view, how do we identify first that the idea is worthy of the market, and how can we take things further if it is, and on those lines, basically.
Great. Thank you, Prashasti.
Yeah, thanks. Yeah. No, so the evaluation of idea is, I would say, really difficult to say how. There's no one way to do that, and because depending on idea, how do we value that idea is a question, right? And again, that valuation also needs to take into account the time scale, right? Whether this idea is able to generate value now, or this idea is going to generate value 2 years down the line or 3 years down the line. So many of the new materials, for example, if there is an idea about a new material which is going to make some impact on, say, biomedical application, right? From that idea to generating value takes long time. Whereas if you have other idea of like a fluidic devices, which I was talking about, if that device works, the realization of that value can start quite quickly, right? So how do we evaluate specific idea or the value associated with that idea? Answer is not straightforward. But I think once you are convinced that it has a value, and then, as I said, one of the best thing to do that is to talk to the target customers or a target audience for that idea, right? That will help you to really cross-check your conceptions about the valuations. And then you need to think about whether it is good idea to develop that idea further and license it, or develop that idea further and create a company around it. Particularly, I'm talking about from the academic researcher's perspective. For a new student, a young student who is not even yet into the academic researcher, but has some idea, I would say that I think those ideas can be explored further, provided some facility or some funding is available for creating that proof of concept development.
Great, thank you. There's a question now from Mohan Karmarkar. Is it the same Dr. Mohan Karmarkar from England? If so, anyway, did you convert batch polymerization reactor to continuous flow reactors, and did the products have the same properties? Mohan, if you want to ask the question yourself, please come on screen.
Right. No, so most of the batch to continuous processes, those were not polymerization reactions. Those were mainly hazardous chemical reactors, chemical reactions like nitrations, diazotizations, and so on and so forth. I've worked with polymerization reactors, but all of those polymerization reactors were continuous right from the beginning, right? So we worked on SAN, polyethylene, polypropylene, but I have never got an opportunity to work on converting batch polymerization to continuous polymerization so far.
Great.
So just
yeah.
just that just at this point, we're sort of coming towards the end of the time we had allocated. We kindly requested Professor Pandit and President Sanjay Mahendra to be here. So maybe just briefly hear from Professor Pandit,
I
and
think so.
and then
Sorry.
we can save some time at the end.
Of course. Sorry, that's my poor chairing. I got carried away by all the questions and answers, and they were so fascinating that I really lost track of time. Thank you, Sid, for sort of pulling us back and wrapping me on my knuckles. Okay. Yes, I think what we would like to do next, we'll come back to. I mean, we won't spare Vivek, of course. We'll come back to you, Vivek.
No problem.
I just in the interest of time, I would like to invite Professor Pandit, who's our Vice Chancellor, to address us. I don't think Professor Pandit needs any introduction to this audience. I consider it a privilege to sort of have known Pandit for almost 40 years, I think now.
Yeah.
And he has been a dear friend. Over to you, Pandit. Carry on.
Thank you, Niranjan. It's great to listen to Vivek as well. Great to see you all. I think the questions which you have posed were quite interesting, and I think you should take up, Vivek, try to answer all those questions. But there were some obvious questions which I could also answer. I hope all of you were able to see today's 12th convocation, where 150 students graduated, mostly with PhDs and masters. If not, I will share the YouTube link, which you can have a look at it. I think, Sid, when you talked about opportunities in India in terms of young students being entrepreneurs or being interested in startups and opportunities available for them, ICT has now a center which is incubating entrepreneurs or incubating startups. Currently, there are 4 of them which are there. Tomorrow, we are having a seminar under the entrepreneurship cell starting at 9:45. And such activities are being generated. We have got some funding and also a certain level of funding from the Department of Science and Technology, and likely to get some additional funding as well. There were 2 or 3 of university alumni which are supporting these activities and taking the students under their wings, guiding them in terms of how they are going to do about it. What Mohan asked about the polymerization continues. Yes, I think the earlier
we've lost
batch emulsion polymerization, the polymerization system that is easily eminently possible. Well, I think this has been a great evening, and I think it is fun to see you all. I think we should have more such events being organized by the chapter, which are outside India, because we keep on organizing things in India, and the UAE is active, and we are going to have another March. I'll tell you more about it, where we are going to inaugurate a biopolymer center, which has been biopolymer center of excellence, which has been supported by Praj with nearly 5.2 crores of rupees as a funding. This is completely ready, and it will be inaugurated on 16th of March in Mumbai in the main corridor. And who's who of chemical engineering, Professor Sharma, Mukesh Ambani, J.B. Joshi, G.D. Yadav, Mashelkar, all of them are going to be there, and it's going to be a fun event. As far as other activities are concerned related to Alumni Association and alumni's contribution to ICT, the President Sanjay Mahendra will say more. I think he will also tell you about the scheduled talk by Dr. Soumya Swaminathan on 1st of April. So activities are going on, but I think what you did, and one particular question which, Vivek, you should answer is the question which was raised, where you have moved about what's the difference you see between the culture and the entire process of getting things done. So I'm very happy to be here and say a few things, and I'll hand over the mic to Dr. Sanjay Mahendra. I'm going to be here for another way. You can continue to contribute to Alumni Association and your beloved ICT, feel free. Thank you, Niranjan. Great talk, Vivek. Look forward to
Thank you.
hearing from you.
Thank you very much. Sanjay, over to you.
Thank you, and good day to all, whether it's morning to evening. I think we are here in the late evening, while in England you are in the afternoon, and I think Ram is early morning at around 10,
Yeah.
right? Okay.
Yeah.
It's great to see all of you here, and the large audience of around 50 people. Right? That of course gives us a kind of a idea about the uh, interest this talk has generated. Specifically, when the speaker is like Professor Ranade, naturally there will be a lot of people who will come in. And Niranjan has Professor Niranjan has been doing a great job. In fact, 30 years back he started this chapter, and this was one of the first chapters to come up in the as a UA alumni association. And for the last 30 years, single-handedly, he has been guiding this chapter, coordinating the activities of these chapters. And kudos to Professor Niranjan for doing that. But I think it is now high time that others join him, specifically the younger generation. Help him to rebuild the entire chapter, whether you call it a UK chapter or the various country chapters, or you are going to call it as a European Union chapters, whatever you wish to do. I really encourage you to do that. And if you can really form a official chapter and form a executive committee, uh, uh, doing the all the chapter works, it will be a great idea. One of the things which all the chapters face is sustainability. Basically, the chapters get started, executive committees are formed, and later on, the chapters do not know what to do further, how to sustain the interest of the members. Now, one of the ways to sustain the interest of the members is having the talks like this. And I think you have sufficient members within yourself who are expert in the various fields. And each one of you, even if you give a talk after a month or two or three, maybe you quarterly one talk, uh, that will sustain, and it will be as interesting as what Professor Ranade has given. Was such an interesting journey when he started right from NCL to where he is now today, and he couple of times went back and came back, and he did a lot of things, and I really am fascinated with that, what he has done. But you have so many of you here who can talk of in expertise of their own fields, and many people will be interested to understand these various topics. And if you can cover these kind of a things every quarter, one kind of a talk, it will be great to have this kind of a thing to sustain these chapters. And I wish you all the best, and hope that you formalize this chapter as early as possible. As Professor Pandit was telling you, we are doing a lot of things here, but I will not bore you with what we do here. Uh, but one or two appeals I will have. See, we are one of the major problems which we have is the database which we have. See, what tends to happen is the database which we have, people tend to change jobs, tend to change their residences, tend to change their email addresses and things like that. So we do not have the your maybe we may not have your current communication uh, email addresses or the phone numbers. Now, if you can give it to the UA office, it will be great, because then we can collate that database and put it on our website, so that you will have a opportunity to interact with the rest of your alumni friends, and that will be a great help. So this is one of the challenges which you are facing, and I like to help us out into this particular aspect of it. The second thing is, of course, as Professor Pandit was saying, we are going to have on the 1st of April a talk by, actually this is a oration lectures which was started by our founder president, Dr. Mariwala, Mr. Kishore Mariwala. He donated a large amount and I started a oration lectures in the names of our past directors of UDCT. And this year's oration lecture is in the name of Professor G.M. Nabar and Dr. Soumya Swaminathan, who was earlier chief scientist of WHO. She is going to talk about the pandemics and its lessons for the society, overall. So it's in the 1st of April on the 10th, and we will try and have it on Zoom as well. And if you can join, you are all welcome to.
I think it'll be early for you because it's
Yeah,
starting
very
at
early.
10 o'clock.
Maybe we will record it also and then put it on the YouTube. So that's something which we will like to do. So I'll not bore you further more on this particular subject, and great to have see you all, and thanks a lot, Professor Ranade and Professor Niranjan, for holding this thing. Lastly, I have one question, Professor Ranade, if I may.
Sure.
Unfortunately, as I see, you started really 10-15 years back converting the batch reactors to the continuous reactors. Unfortunately, I still see in the Indian industry people prefer to go with the batch processes for whatever reasons. Now, are there any particular reasons what you could think about why people still tend to go with the batch reactors, though there are so many advantages of going continuous?
Right. No, so I think one is, of course, the mindset. The other, like typically batch processes, people think that you can operate batch processes without sophisticated process control. That's another point apart from the mindset. And every time you think that process control comes, the instrumentation and process control is an expensive. That's again a conception, right? But if you really convince them that looking at, so that's what I'm saying. So we need to speak language of the language which industry people speak. So you really need to talk about CapEx, OpEx, and overall lifetime cost of a plant. Only then they will get convinced. And it is difficult, obviously, to convince and change the mindset. But I think we have begun the journey at NCL, and I'm quite happy with whatever we could achieve. Looking at so we have about 100,000 small chemical manufacturers all across India. So, and most of them operate batch. So converting from their batch, and I think once their current plants are fully depreciated and they want to change next, I'm sure that they will go continuous.
Great. Thanks a lot, Vivek. I think we're really running short of time.
Sure.
Mohan Karmakar, so glad to see you. Mohan Karmakar was here when we started, we inaugurated the UK chapter.
I'm a graduate with Mashelkar.
Okay.
Same batch.
Same batch, yeah.
I will just make one comment about why in India or even in UK, why batch reactors are used. Because majority of the chemical processes are developed in the lab by the chemists who use cubes, 1 liter glass reactor, which is batch. They are not developed straight away as continuous flow reactors. And until it is proven that way, that it is possible, people will still use batch.
Yeah, I'm planning to teach continuous reactors to chemistry students now.
Okay,
That's
great.
very good. That's what we need to do.
Yeah.
Okay.
Niranjan, can I?
Hi, Palakar. Hi.
Hi. Can I comment on what Vivek added and what the Professor Karmakar
Sure.
added?
Quickly,
Based
yeah.
on my experience in industry,
Yeah.
what Vivek said and what Professor Karmakar said makes sense, a lot of sense. I have worked at Atul Limited for 7 years, where I tried to convert some of the batch processes into continuous. One of the process which I have done thanks to the support I got from Professor Sharma when I was there was phosgenation chemistry, which is one of the very tough ones.
Correct.
Okay. We converted batch process from a 8.5 KL reactor to just 350 liters reactor. It was a cascade reactor. And we initially and I can tell you, when I first put up what Vivek said is absolutely true. The mindset is the biggest challenge in the chemical industry. And as Professor Karmarkar said, the biggest problem is most of the processes and operations in industry are controlled. I would put it controlled in the inverted comma by the chemist who don't understand the chemical engineering aspects of it. What I did in Atul when I joined, all my plants were operated by chemists. First thing I did was I changed them to chemical engineers, and that's where I could do some of these changes. Interesting part is when I proposed this phosgenation technology in continuous mode, our management sanctioned me 25 lakhs for the pilot plant. And I can tell you, not a single guy from my team agreed to even do the pilot trials. Ultimately, I, along with one of the UDCT students who was working in my R&D, did those trials. I was the president. I said, I care hell about it. I will just stand there and do it. When I did it successfully, ultimately the technology team took over. Today, Atul runs two reactors of 1,000 tons of continuous phosgenation, which I'm very proud about. That from a batch process, and possibly Atul is the only company after BASF to do phosgenation in a continuous mode for the specialty chemicals.
Good.
So it's a quite challenge. We also converted sulfonation technology using a different process, slurry reactor, which was in a screw reactor, which we did up to a pilot level. And along with Professor Pandit, we tried to do crystallization in a continuous way. And I can tell you, we went up to pilot level. We successfully showed it, but still my team refused to do it on a commercial level. So it's always a challenge to convert batch processes into continuous. And today, as an advisor and consultant to chemical industry, I've been trying to convince many companies to go into continuous processes where you can find a lot of advantages. Fortunately. Sure. But it doesn't happen, unfortunately.
Thank you very much for those insights, Palekar. It's a long time. Good to see you after a long time.
Same here.
Okay.
Thanks.
Right. Now,
Vivek, Vivek, I will call you separately, yeah, Vivek.
Yeah, sure.
Okay. Just before, I mean, now the trouble is looking at the people who have spoken today. I wouldn't, I mean, we have quite a few youngsters in the audience, and they may think that you either have to have gray hair or you should be follically challenged if you want to participate in UDCT functions. So just to challenge this view, I would like to invite Abha Valavalkar to say the final word. She's going to give the valedictory address. So it's an important work that she's going to do. Abha actually is a graduate of UDCT. She did her dye technology in 2019. Then she did her master's degree. 1 second, let me get her. Here we go. Yes, and then she did her master's degree at the Friedrich Schiller University in Jena, Germany, where she's also doing her PhD under Professor Benjamin Dietrich Ivanisik in the field of ultra-fast time-resolved spectroscopy for functional chromospores in live cells. Abha, I haven't got a clue about what this means, but I'm sure it's a very impressive subject. Over to you, Abha.
Thank you so much for the introduction, and thank you so much to everybody who's come here today. I know it's quite late in India, and we feel really encouraged that all of you took out the time to attend this. And like, even though it's so late, this started off, as Professor Niranjan said, where we realized there's more and more people in Europe, and we wanted to get together partly because of nostalgia, like talking to everybody, listening to everybody talk about processes. And because now I'm doing spectroscopy, so it's been a while since I heard the words batch reactors and continuous processes and sulfonation. So it was also very nostalgic and very nice. So we want to sort of get in touch more and more with ICTians in Europe, who we've realized are now growing quite fast. And for that, we're very, very grateful to everybody who came out today. I would like to thank Professor Ranade for this wonderful, wonderful talk and the very nice discussion that followed. I would like to thank Professor Pandit. I think he dropped off because you're on the call, but the Vice Chancellor, Professor Pandit, for being so encouraging and inviting us to have more of these events. I would like to thank Dr. Mahendra once again for all the support that UAA has given. We've been in touch with Dr. Ram Sabnis, who's on the Board of Governors, and he's really helped us work with UAA also in terms of what we can do, what is in the directives right now. I would really like to thank Professor Niranjan and Dr. Ram Sabnis, because they were the ones we sort of got in touch with, and they have done a lot of handholding for Sid, Bhargav, and I. So Sid, Bhargav, and I were the three people who started working around this, and Professor Niranjan and Dr. Sabnis were just there streamlining the whole thing for us. And I would like to thank Professor Gokte, Prashasti, and Secretariat at UDCT for taking care of the technical stuff, also for sending out the invites. And of course, Sid and Bhargav, because I mean, the three of us have been at it for quite some time, because there were a lot of questions we had starting out. But Professor Niranjan, with his wisdom, has been there to sort of make the process more smooth. And I would like to also thank all of you, because I mean, it's, I think, 11:30 or something in India, and it's quite late for Saturday evening. Saturday
Only
night.
9:45. Don't worry.
Oh, perfect. My math is then clearly gone. But I mean, thank you so much for all of you. Thank you so much to all of you for making this Saturday evening so nice and so lovely.
Great. So
And if you have any ideas, if you have any suggestions, to especially to those who are in Europe. So right now it was just the five of us doing all the brainstorming. If you have ideas, suggestions on what events we can do next, what to do next, please feel free to write to us. I will write our email addresses in the chats once again, so you can have them right away.
So
just an interruption here from Vikas London. I was told in one of the communication that there will be a WhatsApp group, etc., so that the contact is easy and faster also. So I have not seen it. So anybody wants to take, and I can take a lead and do that.
Great.
Thank you.
Okay, thank you, Vikas. Yeah. So thank you all very much. I think we've had a great afternoon or evening. I certainly enjoyed it, and I know it's Vivek has sort of appetized an area, and I think we all have more questions, more food for thought. But let's keep this dialogue going, and let's also keep UAA flag flying. Thank you all very much. Bye bye.
Thank you.
Bye bye.
Thank you.
Thank you.
Bye-bye.
Bye bye.